Okay, got y'all. With Mythbusters, the explosive exhibit. These are amphibious bicycles. Yeah. Oh, I remember that one. Duct tape. I saw that. The guy bet him they couldn't make a boat out of duct tape. And they said, you can do anything with duct tape. Yeah. Oh, this must be something you fly with. Yeah, those are rotors underneath, I believe. Yeah. Yeah, I like to fly.
If there's anything you want to take your picture with,
Do it.
Oh, it's a jetpack.
you don't get
Oh, but it didn't work.
Cameron.
See, it busted.
Here. Cameron.
Okay.
Yes.
All right. See if you're on a desert island and you have enough duct tape. This one? I remember you had to make sure there was no leaks. Yes. Yeah, duct tape, desert island, escape, outrigger. Yes, it worked. Come here. See? Confirmed. Yes, you can do it. There they are in the boat. So if you're on a desert island, make sure you have enough duct tape.
The methodology is always the same. At the end of the episode, we always call it busting.
Okay. Oh, where's the most germs?
Good luck.
Keyboard, yeah.
All right, do you know where? Which one has the most germs? Huh?
Money probably, I don't know.
Kitchen sponge, I think. Kitchen sponge is wet, stays wet, soaks up food, germs just love it. Money's got drugs on it.
This is science. Isn't it
Computer
great?
keyboard,
Believe it or not,
dirty from your hands.
method to our madness.
Policy gets cleaned every once in a
And
while.
it is the foundation on which all the experimentation will be built.
Right. Scientists have been using it for a long, long time.
Yeah, way before us.
The scientific method uses observation, investigation, and experimentation to test a hypothesis. And so on our show, you may have heard us say that we replicate the circumstances of the myth and then try to duplicate the results.
Right. See, first we try and test the myth as it's stated to see if we can get the expected results. If that fails, we will then expand the scenario to get those expected results no matter what it takes.
Yeah, if we really push the limits in order to test the myths, then the results are measured in a way that's scientifically appropriate to the experiment. That way, whether we're blowing up a cement truck, polishing a truck,
Yeah, I guess so. Yeah. Come on. Over here.
This episode of Mythbusters, we took a group
Now, thanks to Adam J, you know that nobody can dodge a sniper's bullet, even from 275 meters away, because the bullet travels faster than we can react.
But you know, Gray, I was wondering, we could test to see if we can dodge something that's still dangerous, but a little bit slower.
Okay, like what?
I was thinking, oh, maybe a paintball.
Oh, yes! You knew you couldn't come to a Mythbusters exhibit without us cranking up the danger, right?
All right.
Now, one of you is going to end up in the firing line trying to dodge one of those paintballs. But before we get to that, we need to take some predictions of what you guys think of this. Now, raise your hand if you think a person can actually dodge a paintball.
Couple of people.
Okay. Now raise your hand if you think, no way, nobody can dodge something that fast. Okay, looks like we have
Hey, it
no.
looks like most of you said no, so we just made a prediction, which sounds like a hypothesis, which is part of the scientific method. Now, on the Mythbusters show, the hypothesis is the myth.
And the Mythbusters use the rest of the scientific method all the time on the show, too. Now, who can tell me the different parts of the scientific method? Since we have our hypothesis, what are some other different parts of the scientific method? Anybody? Pardon? Pardon? Trials, perfect. Our trials are experiments. Excellent. Yes. Sorry? Data. Also, we collect the data from our experiment, and what is our last step? After we have all our data? Conclusion. Perfect.
Okay, so when we asked you before if you thought someone could or couldn't dodge a paintball, not everyone raised their hands. Are some of you guys thinking maybe someone could dodge a paintball?
Yeah?
Anyone want to tell me why you think maybe?
Put an umbrella in front.
That's
Sorry?
not dodging it.
Why do you think maybe?
She thinks a barrier. She wants to put a barrier in front.
Okay, any others? Yes?
You could.
But that's not
I'm
dodging.
sorry?
No, it is
Okay.
dodging it. It's not gonna get
Because
you.
you can slow the thing down, okay?
Okay.
So yeah, it depends on different variables, like, say, distance. So let's say if I was standing just half a meter away from the paintball rig here, do you think I could dodge the paintball? No, I'm standing way too close. But if Gray was standing like 2 football fields away, do you think he could dodge the paintball? Yes, he's standing farther away.
So before we start shooting for science, we need to design an experiment that takes the it depends out of the equation. And in the scientific world, they call this controlling the variables. Now, we can control almost all of our variables with our paintball rig here because it travels at the exact same speed every time, 76 meters per second, equivalent to 275 kilometers an hour. It's mounted to the floor exactly 7.6 meters away from our target, and it has a delay built in, so it will fire between 0.1 and 1 second after we push the trigger on the rig. By setting the delay on the rig, we can simulate a variety of distances from which the paintball can be fired.
Here, I will show them what we mean. So, if we want to give someone, say, just 7.6 meters of reaction distance, which is only 0.1 seconds to get out of the way, we don't need to do anything to our paintball rig here. We just fire as is. There
Press
we
the
go.
button.
We don't add any delay to it. So when I press the button,
That's
it
right.
goes off right away. But now,
But
if
if
we
you can
want to
anticipate,
simulate someone,
then you
simulate
can
a paintball
dodge.
being fired from a longer distance, let's say 76 meters, we can't just pick up this great big paintball rig and move it farther away, it's sitting on the floor. So instead, we set the delay between when I press the button and when the paintball hits the gong up to 1 full second.
Oh, okay. See, that's different.
Now, when I press the button,
1,000!
so the amount of time between me pressing the button and the paintball hitting the gong is the exact same amount of time it would take for the paintball to travel 76 meters.
Excellent. So what we can control is the variables of the paintball gun, but what we cannot control is how fast a person's reaction time. So we want the fastest Mythbuster out there to come and volunteer and be our paintball dodger.
So before the show, we found 3 very, very great volunteers. Let's bring them on up. Come on up here, guys.
Give a round of
Each of you
applause.
stand on one of these pink
Great
X's. Come on up.
Excellent.
Okay.
Okay, go ahead and stand on one of those
Stand on
X's.
the next, please.
We are going to give each of our volunteers a buzzer that will measure their reaction time. When we give a cue, the timer will start, and the timer stops when they smack the buzzer. That way,
I
our
don't know.
computer can record the
I don't
results
think
and
it
we
can
can
be
see who the
turned.
fastest reactor actually is. And the fastest reactor out of all of those 3 volunteers
Oh, I see.
will get geared up and be dodging a paintball.
Okay, and I think we also need to mention here that our paintball rig has a light cue and a sound cue. So I think we not only need to test who is the fastest, but what kind of cue they respond faster to, light or sound. And that way we'll know the right type of cue to use with the paintball rig to give them the best chance of dodging.
Excellent. And you know what the best thing about science is?
What's that?
There's always new questions to ask and new experiments to do. And since this is a new experiment, we can come up with a new hypothesis. So who believes that our lovely test group will react faster to a light cue? Yes, can you tell me why you think that? It's visual. Excellent. Yeah, perfect.
Light travels
Who
faster
thinks
than the speed
our
of
test group will
sound.
react faster to a sound cue? Can you tell me why? Because they can hear it? Perfect. Excellent answers, guys.
All right, I saw a couple more hands go up for sound cue. So if you think that's the fastest, that is a reasonable hypothesis. And great, I think we're ready to go for our first test.
Okay, so we're going to start off with a light cue. So as soon as you see this bulb light up right here, you're going to smack the buzzers as fast as you can, and we will see who the fastest reactor is. Let's give it a round of applause.
Woo! Now, for everyone in the audience, we haven't forgotten you. You guys have buzzers as well. You may not have seen them, but you do. Oh yes, they're right behind you. Take a look.
Oh, good.
They're invisible.
Oh.
But they're still lots of fun, I promise. So let me buzz along with these guys. Everyone put your hands out like this. And 1, 2, 3. Oh, well done. So you can buzz along with the rest of the gang.
Great, so again, starting off with our light cue, all of you guys in the audience can participate as well by smacking those buzzers together. Are you ready, guys? This is reaction time, test number 1, light cue. Oh, didn't go off yet.
Oh, okay.
Oh no, I didn't even press it. He just jumped again. Okay, we're ready. Wait for that light to flash. Okay.
All right. I heard a couple of buzzers going on in the audience. Perfect. Great. What were the results of that test?
Our fastest reactor was green with a time of 0.500 seconds and an average of 0.625 seconds.
Okay. Woo. Fantastic.
Okay, so now we're going to do our sound cue. So as soon as you guys hear the sound cue, smack the buzzers as fast as you can again, and we can record the results.
All right.
This is reaction time test number 2, sound cue. Excellent.
Okay, there's more buzzers going on in the audience. Great, guys. And Ray, what were the results of that test?
Okay, this time our fastest reactor was green, again with a time of 0.450 seconds and an average of 0.550 seconds.
Okay, so now we've done a couple of tests. What do our results tell us? Did our tester respond faster to light or to sound? Sound, that's right. So was our hypothesis confirmed or busted? Confirmed, and it was the gentleman with the green buzzer. I believe it's the fastest. And your name, sir? James. So James, I have a very important question for you. Are you ready to see if you can dodge a paintball?
I'm ready.
He's ready!
Let's give it up a round of applause to our other volunteers for helping us conduct this experiment. Thank you guys so much. Now, I did some research recently and found out that according to several research studies, we respond faster to sound cues than we do to light cues. And this has to do with how our brain processes different stimuli. Our brains can actually process sound information faster than they can light information. Now, while they're getting set up back there, I want to remind everyone that this is a do not try this at home experiment, okay? If you guys have paintball guns at home, don't try this at home. Not that you would have paintball guns at home. Anyway, while they're getting set up back there, there's a reason why we are giving James a face mask, a neck guard, a padded lab coat, and being given a riot shield.
There we go. All right, James, here is your shield. So now, because you responded fastest to the sound cue, we're going to give you that sound cue again, so you know when to jump out of the way. So when you hear that cue, just jump. It's okay if you crash into the walls. They're padded, totally safe. Words to wise, keep your elbows tucked in, and keep that riot shield up over your face. Are you ready?
He's ready.
He's ready. Let's give James a round of applause.
Now, I have a lot of confidence in James, so we are going to start off with 0 seconds of delay and increase the time from there, okay? Are you ready, James? This is test number 1, dodging a paintball with 0 seconds of delay, equivalent to being 7.6 meters away.
That was close. I think we need to give him just a little bit more time, Ray.
I think so too.
That was pretty quick.
I know. I love trying to see our contestants try to dodge with no delay. So we will increase the time to 0.4 seconds and do another shot, okay? James, this is test number 2, dodging a paintball with 0.4 seconds of delay, equivalent to being 30 meters away. Oh. Oh.
Ooh, okay, we're getting a little bit better here. All right, no, it's a little bit slippery. Okay, so Ray, I think we should give him just a little bit more time, a little bit more delay. I know we're going to have a successful dodge soon.
Okay, I think so too. So we will increase the time to 0.7 seconds of delay, equivalent to being 53 meters away. Let's give it up for James.